This lecture is on metric conversions. Metric conversions are very similar to the dimensional analysis unit conversions we were just doing. Two main differences are, first, the relationship is not going to be provided, so you need to learn these metric prefixes. And second, that these relationships are rather large powers of 10, and so knowing how to use scientific notation on your calculator would be very helpful. As far as memorizing these metric prefixes, I don't know a good mnemonic. I used sort of a rhythm to try to memorize these way back when I learned them. You can maybe make up a different rhythm: kilo, mega, giga, tera, peta, deci, centi, milli, micro, nano, pico, femto. So sometimes rhythm or a little bit of a tune can help you remember them. Or if you find another mnemonic, please let me know and I'll share it. But these have to be memorized. And this order that you can remember with your rhythm corresponds to, for the larger prefixes, going up by 10 to the third each time. 10 to the 3, 10 to the 6, 10 to the 9, 12, and 15. This one, we have a couple extra. Instead of starting with 10 to the negative 3, we have 10 to the negative 1 and 10 to the negative 2. And then after we get to negative 3, then we go negative 6, negative 9, negative 12 by threes. This is what the prefix means. So the prefix deci means 10 to the minus 1 and is abbreviated with a small d. What we need to do the conversion is not just a number, we need a relationship. We need to know that 1 decigram is equal to 10 to the minus 1 grams. And it is not correct to say that 1 gram is equal to 10 to the minus 1 decigrams. So the first step in being able to successfully complete a metric conversion is to be able to write a metric relationship. So if you know that milli means 10 to the negative 3, milli equals 10 to the negative 3, then milli equals 10 to the negative 3 here. 1 milligram equals 10 to the negative 3 grams. Nano equals 10 to the negative 9, so nano equals 10 to the negative 9. One side will have the prefix, the other side will have the power of 10. 1 nanometer equals 10 to the negative 9 meters. If you put the power of 10 into the wrong blank here, you'll end up with a relationship that is not true. You need a relationship that's true in order to do a correct conversion. Deci equals 10 to the minus 1, so 1 deciliter equals 10 to the minus 1 liters. Micro equals 10 to the minus 6. Micro is abbreviated with a Greek letter mu because the letter M is being used for too many other things. So micro equals 10 to the minus 6. 1 microsecond is 10 to the minus 6 seconds. Let's go ahead and practice these conversions, writing the relationship first. 1 kilogram equals 10 to the 3 grams. With this relationship, we can make these two conversion factors. We need to use this one to be able to cancel grams. So this answer will be in kilogram. Now what remains is to be able to divide 83.8 by 10 to the third. If we want, we can take this 10 to the third that's in the denominator and bump it up to the numerator, changing the sign. So dividing by 10 to the third is the same as multiplying by 10 to the negative third. So now we just either need to convert this to a standard notation number or to a true scientific notation number. 83.8 is the same as 8.38 times 10 to the 1. And this times 10 to the minus 3 would be 8.38 times 10 to the minus 2 kilograms. That's one way to write the answer. or we can just write the answer as a standard number, 0.0838 kilograms. Notice that we don't have to worry too much about significant digits with a metric conversion. We just keep the same amount of significant digits. We had 3 significant digits to start with. Metric conversions are all exact, and we have 3 significant digits in our answers. For example, B, this is our correct relationship. 1 microliter equals 10 to the minus 6 liters. We can use either of these conversion factors coming from that relationship. Since we are trying to convert liters, this is going to be the more useful conversion factor. If you divide 0.087 by 10 to the minus 6, that's the same as multiplying it by 10 to the 6. This is still not finished because we need to put this in either scientific notation or regular standard notation. If we convert 0.087 to scientific notation, we get 8.7 times 10 to the negative 2, and then we can multiply this by 10 to the 6 to get correct scientific notation of 8.7 times 10 to the 4 microliter. Or we can convert this to standard notation, 87,000 microliters. This last one is going to need 2 steps, unless you know how many nanometers are in a gigameter. Most students know 1 nanometer is 10 to the minus 9 meters, and here are the 2 conversion factors that come from that relationship. And 1 gigameter is 10 to the 9th meters, and here are those 2 conversion factors. And I think before I start, I'm going to go ahead and put this in scientific notation already. Here we have 63.11 nanometers being equal to 6.311 times 10 to the 1 nanometers. Next, we need this conversion factor to convert from nanometers to meters. And then we need this conversion factor to convert from meters to gigameters. Our nanometers cancel and our meters cancel. We're going to be left with gigameters. If we gather all of these powers of 10 here, we're going to have to take 1, subtract 9, and then subtract 9 again. So that is 6.311 times 10 to the negative 17 gigameters.